it's my pleasure to start with Alex Thornton from the Linux Foundation Energy. He will share with us the latest on open source and why it's important for e-mobility. So give him a warm round of applause. And Alex, the stage is yours.
Thank you. All right, thank you. Morning, everybody. This is definitely the coolest place I've ever gone for a conference, right? We got people sitting in lounge chairs with sunglasses on. That's awesome. Okay, and I should get out of the way of the screen. So, hi, I'm Alex Thornton with Linux Foundation Energy. And I'm going to talk to you about how we can solve EV charging reliability through open source. So this is the problem. Most people, when they think about refilling their car, they think about this experience. And it is beautiful in its simplicity. You pull up, you grab the gas nozzle, and you put it in the standard hole. And it just plain works, right? You don't even need to use a credit card. Sometimes you can even pay cash. It's fast, it's efficient. And this is what everybody's going to compare their EV charging experience against. It's a tall order. And if you look about how EV charging works now, it is very complicated. You have all these numbers and letters and all these different boxes that need to communicate with each other, right? The EV needs to talk to the EVSC, needs to talk to the CPO, the EMSP. Maybe you're roaming, so you need to do that, and you got to talk to the power system, make sure there's enough capacity, and then you got to send it all back to the EVSC so it can actually deliver the energy, and the EV needs to say that's enough. And this all needs to happen in real time. It needs to be secure. It needs to protect your private information. And it's really challenging to do that with every kind of car, and every kind of charger, and every kind of charging network. And not just once, but with all of the updates and permutations that happen, right? It's not just the implementation of it, but it's the maintenance of all these things and all the different permutations of them working together. Now, the good news is we have all of these numbers and letters, these standards that define how the different parts communicate with each other. And that's super important. But I don't think it's enough, because we still have reliability and interoperability challenges, right? In the US, 1 in 4 charging sessions fails. That's awful, right? You're not going to get an EV if 1 out of 4 times you're going to be stuck. You're going to stick with your ICE engine and you're going to wait until the infrastructure improves. But we don't want to wait. We want to move forward. So I would say this is a software problem. We have standards. We need to actually implement the standards, and we need to make sure that they work together reliably. And we need to do it in a way that's efficient, so we're not reinventing the wheel. So in the tech industry, we have ways of building software quickly, efficiently, reliably. So let's just go through an exercise. How many people in the crowd is a software engineer? Okay, a couple of you. All right, so you're going to know what I'm talking about, but people who aren't, it's going to be very easy to follow along, right? So I'm a former software engineer, CTO, so we'll dust off the skills here and think about building an application. So, all right, let's start. You need something to edit your code. We'll use Visual Studio Code. It's nice, easy to use, free. I like using Python. Easy to use language, can do a lot of different stuff in it. If you're building a web app, I like convention over configuration, go with Django, batteries included framework, you'll go fast. And you need something to store state, Postgres. You can't make a mistake there. It's good general purpose database. Okay, cool, then we do some stuff with our application, but we need to deploy it now. Okay, let's containerize the application. Well, we need a runtime for the container, so let's choose Ubuntu. We need to orchestrate the deployment, so Kubernetes. And then we want to be able to observe what's going on. Let's use OpenTelemetry with Prometheus, right? So this is how every software engineer gets started, right? You may make different decisions, But these are the general purpose building blocks. If you're not doing it like this, you're doing something wrong as a software engineer. That's not controversial at all. Now the interesting thing about all these is they're all open source, right? These are the foundational building blocks for the tech industry. All modern technology built on top of these open source building blocks. Everything, closed source, open source, you name it, these are the foundations. And so it's to the point where everything, right? Like Microsoft Windows, Word, like the most proprietary software in the world is built on top of 80%-ish open source building blocks. And then they sprinkle in maybe 20% of their own code on top. That's how we make modern technology. That's why we're able to move quickly, move securely, and limit investment in rework, because we share the effort on these building blocks. So I'd like to say open source is just a way of collaboration. That's really all it is, right? So instead of 3 organizations building their own foundation and then competing on top, they share the investment, they move faster together, and then they compete on top of that, right? So there's still plenty of space to compete, to innovate, to have your own intellectual property, your own strategic innovation. It's more the pre-competitive part. Now, to clarify what open source means, in case folks aren't familiar, it means anyone can view it. Anyone in the public. You don't have to have a password or be a member of anything. Anybody in the world can view it. Anyone can modify their own version of it, right? So this doesn't mean anybody can modify the shared version. Only special people can do that. But you can make a copy, edit it to your heart's content, or you can propose a change to the shared version. And anyone can share it according to the terms of a license. So, examples of this. So this is Citrine OS, which is an open source charging station management system. Here's the code. You don't need a password to see this. It's all public on GitHub. And here's a pull request proposing a change to the code. Again, not anybody is allowed to accept the change, only special people with permissions to do that. But anybody can propose a change. And here's the license that says, you know, if you choose to use this as one of your building blocks, this is what you're allowed to do with it. And in this case, Apache 2.0, very friendly. You can go ahead, wrap it up in your own commercial proprietary product and get rich off of it. Go nuts. It's great. But going back to those standards, how does what I just talked about with open source fit into, you know, IEEE 2030.5, OpenADR, OCPI, OSCP, all of these different standards? Well, this is how standards traditionally have worked, right? And we, you know, the world has collaborated on standards for hundreds of years. Super useful for, you know, aviation, flights, you know, electricity, all sorts of things. Very important for us to have interoperability. And the way it would work is you would identify a common problem, and that would be kind of the scope of the pre-competitive collaboration. And then you'd work together on, okay, how are we going to solve this problem? And then you would end up with a stack of papers that say, here is how we will solve the problem. And that's good, but it's just paper. It doesn't actually do anything. It's, you know, maybe you can read it if you're having a hard time falling asleep, but it doesn't do anything on its own. And so if you want to turn those pieces of paper into something that's actually useful and solves the problem, first you need to interpret the standard, and anybody who's ever worked with standards knows that they're not perfect. There's ambiguity, there's gaps, right? And so I may interpret the standard as meaning one thing, you may interpret it as something else. And so we end up with non-standardized interpretations of the standard. And you may not arrive at the interoperability that you were hoping to achieve. Well, that's a problem. And then even if you have consistent interpretations, you have to implement it. You have to turn that paper into working code. And there's nothing special about that, right? Software engineers may say it's special, but it's not really that special to turn pieces of paper into working code. And this is already in the scope of that pre-competitive collaboration that was defined around the problem that the standard is meant to solve. And so only after you've interpreted and implemented the standard can you actually do what's unique to your own company or strategic value add. Now, if you compare this to our little exercise of building an application using open source building blocks, this is nuts. We're doing it the wrong way. We're going slow. We're reinventing the wheel. So a better way is to expand the scope of that collaboration a little bit to the right and include the interpretation and implementation of that standard. So then you have shared, consistent reference implementation. You ensure interoperability, you share the investment so you know that thing is bulletproof, it's secure, it works well, it actually solves the problem that the whole collaboration was meant to solve. And then you go ahead and compete on top of it. Nothing about this prevents that competition. And if you want to do even better, you actually have the reference implementation, the technology interact with the standard. Anybody who's built technology knows that it's nearly impossible to do this waterfall type development, to specify all the requirements at the beginning, throw them over the fence and expect it to actually solve the problem. That never works in product development. It's always iterative, it's agile. So why don't we do that with implementation of standards as well? Develop the standards in parallel with the code. Each one influences the other and they make each other stronger. So this would be a great outcome for all the complexity that we need to solve with EV charging. So one of the laws of physics of open source is it climbs up the supply chain and continues to commoditize higher levels of abstraction of the stack. And we saw this with the previous example. We had Linux on the bottom, and then you go a little bit higher and you have Python, and they have Django higher up, right? So industries have found that you can continue going higher and higher up the supply chain with higher levels of abstraction. They solve industry-specific problems. So I'm going to talk to you about some industries and examples there that have done just that. This is my favorite because oftentimes software is not as visually appealing as this, but this is gorgeous, right? These are all our favorite movies, Avatar, Spider-Man, you name it. All of them use CGI. And the movie industry realized this, and they all realized, well, gosh, all of us use CGI, but nobody really cares how nice our water is or like what we use to make our explosions. There's a lot of commonality across this. And so they created what's called the Academy Software Foundation, and they decided, okay, we're going to collaborate on some building blocks here. And what you get are things that look this nice. And the interesting thing to know is you have Sony, Disney, DreamWorks, right? Companies that are competitive with one another, working together. You have Google, Microsoft, Amazon, they compete with each other, they're collaborating. And also the studios, the Disneys represent the customers here, the Microsofts represent the vendors. So you have competitors collaborating and you also have customers collaborating with their vendors. And this is a common model in open source. Cars, right? In the 80s, they were mostly analog, and the lines of code has exploded over time. These things are rolling computers with hundreds of millions of lines of code, and it's only going to increase, right, as we have more and more EVs, and especially more autonomous vehicles. So how do we apply those best practices of open source to this problem? There's automotive-grade Linux. Same idea. You have Toyota, Mazda, Mercedes, Volkswagen, Suzuki, and others on kind of those foundational things, right? So you have kind of like all of the low-level technology required to make the car work, and then you put your own infotainment skin on top. So a Mercedes looks like a Mercedes, a Mazda looks like a Mazda, but under the hood, it's a lot of the same code. Telecom and networking. 70% of global mobile subscribers are on networks that are running open source. Same deal. You've got the telecom networks, the T-Mobile, Verizon, China Mobile, working with their vendors, Ericsson, Cisco, Infosys, Nokia, on this shared platform. And then the last example I give, banks, right? We don't usually think about innovation and collaboration when we think of banks, right? We usually think of, someone like Gordon Gekko and Wall Street. Greed is good. But here they are collaborating with fintech companies, especially around regulatory R&D. Because they realize it's too much for one bank to deal with on their own, and it's not differentiated. The value is building this shared platform. So with banks, that leads to the other question. Open source sounds great. You get to share this investment. Wonderful. But how do you make money? Right? We have a lot of for-profit businesses here. You need to eat. Well, it's a business strategy. So as much as open source is a technology strategy, it's also just as much a business strategy of understanding, well, what part of your business, your technology, actually is not a moat? What is worth collaborating on instead of holding close, right? And when successful, you have projects that lead to commercial products that lead to profits. And the cycle continues. The profits feed into the project, and so it's sustainable. And this is really important because the alternative is you have some sort of hobbyist project where somebody's working in their basement nights and weekends on, passion project, which is nice until it becomes a critical piece of infrastructure. That person gets burnt out and the web falls down. So that's a bad outcome. We would rather have organizations that align open source with their own business strategy, with their own revenue model, so that people are getting paid to actually work on this stuff during their 9 to 5. Now, open source is a business strategy. It's also a good one, because if you look at the most valuable companies in the world, Microsoft, NVIDIA, Alphabet, Amazon, they're also the most prolific open source contributors as well. Think about that. They've cracked the code of how do they give away technology for free and turn that into their own business value. They've used open source to create strategic value of their own, and then their value has skyrocketed. Microsoft is my favorite example to talk about with this. A couple of decades ago, you had Steve Ballmer talking about developers, and also at the same time saying Linux is a cancer. Microsoft very, very actively tried to squash Linux and open source because it saw it as a threat to their proprietary license model. They failed, obviously. About a decade later, you have a different CEO, much less sweat, and he says Microsoft loves Linux. So a complete 180, turned the industry upside down. And after that happened, stock price goes through the roof. Right? And up until NVIDIA claimed the throne, I think they were the most valuable company in the world. And it's because they embraced new business model that they were able to capture all that value. They saw the cloud coming. They saw that Windows licensing was not going to be what people used in the cloud. And so they had to, if you can't beat them, join them, so they embraced Linux. And they said, this is a business opportunity to offer heterogeneous support. Right? It's about customer centricity. How do they collaborate with their customers, actually solving problems, deliver value, and turn that into value for Microsoft? And now if you look, I think Linux powers the majority of Azure workloads in the cloud. Right, so open source is a business strategy. Now let's talk a little bit more detail about what some of those business strategies could be. There are different ways that you can generate revenue around open source. So one is you could use it to lob bombs into a market to strategically disrupt it. So Google did this years ago. If you remember, AWS was kind of the first mover in the cloud provider market. And they had a lock on that. And they had a bunch of proprietary products, interfaces around how do you orchestrate containers, how do you interact with it. And GCP wanted to claw some of that market share. So what do? They create what has now become the standard in container orchestration, Kubernetes. And they did that to improve portability of applications. So it was easier for them to steal from Amazon and have it run on Google Cloud. And you know that they've won because now Amazon has a product for Kubernetes and is contributing to that project as well. So it's a huge victory for Google and the industry overall. Now you can You can run your application on Amazon. If you don't like them, you can pretty easily switch it over to GCP or Azure or a dozen other cloud providers. So it's great for us as consumers as well. Another model, support and services. Right? If you're a company, most often you don't want to actually operate, maintain open source projects, right? You want somebody who can just take care of it for you, provide service, provide maintenance, give you somebody to call if something goes wrong, give you somebody to blame if something goes wrong. Sorry, it wasn't me, it was the vendor. And that's what Red Hat does. So they create these enterprise-grade products around free open source projects. So all of their software is free and open source, but their subscription for service, maintenance, documentation, training, they charge for that. And it's been incredibly successful. Hosting. We talked about Kubernetes, but that's an open source project that cloud providers host. So they don't charge you for the software itself, they charge you for the infrastructure that's running on. And to the customer, it lowers development friction. It's great. Consulting, right? Oftentimes, it's not just one application that you need a system of applications. You need them all to work together. It's great for consulting because you can charge billable hours to basically fill in the glue that ties all these different systems together and make them work great. So there are a number of companies that invest heavily in the open source ecosystem, develop expertise, and then go ahead and sell that as consulting. Dual license. You can have a core open source project that maybe satisfied some base case, small scale case, but then there's an enterprise commercial version for larger scale or more features. And then the last example I give, hardware, right? So software is the complement to hardware. You need drivers, you need interfaces between the hardware and software to make sure that your hardware works really well. The cheaper and the better that software works, the easier it is to sell your hardware. So you have a number of hardware companies that get into the software layer just for that, so they can sell more hardware. All right, so by now, you understand a little bit more about what open source is, how it fits into EV charging reliability, standards, business models, right? The next question I usually get is, yeah, but anybody can see it. There are hackers out there. Isn't that insecure? Isn't that a problem? And I'm going to say no, because already any proprietary software that's being built, that's being purchased, it's already using open source under the hood. You just don't know it, right? And so what vendors do is they take all these open source projects, they put them together, they sprinkle in their own code, they put it in a box, put a ribbon on it, and they sell it to you for a lot of money. And you have no idea what's inside. But I guarantee you, open source is already inside. And you assume it's secure because the vendor says, don't worry, I got it. But you have no idea. The other point I'll make, Linux and open source are already everywhere. Linux, 90% of the public cloud, 62% of embedded market, 99% of supercomputers, 82% of smartphones. So if open source is insecure, then that means Linux is insecure, and that means we're all screwed. So let's just give up. But fortunately, that's not the case, right? Linux is secure, we're not all screwed. That means open source can be secure. I want to emphasize, it's not secure by default. No software is secure by default. But it can be. So let's imagine after this talk, we go out to a restaurant, and we're picking two options, right? One is closed kitchen. You're not allowed to see, if the chef is washing their hands after they go to the bathroom. You're not allowed to ask about any of the ingredients, where they come from. But they say, trust us, it's great. We follow best practices of hygiene. Our supply chain is phenomenal. We massage the cows every day and read them stories. It's great. But you can't see any of that. And the other option is completely open kitchen. right? You can actually look, you can follow the chef to the bathroom and just make sure, yep, washed your hands, you counted to 20 seconds, you're good. You can go to the farm, you can talk to the cows, see if they're actually being treated well. Which would you trust more to deliver you high quality, healthy food? You would trust the transparent one more because you could actually scrutinize it. And so that's really the key difference of open source is transparency. That's the main difference, right? With closed source, you have restricted viewing access. You just need to trust the vendor. Whoever packaged it up, just trust, yep, they got it. But what that means is you have no idea what bugs and vulnerabilities are there. And I guarantee you there are there. And you also are at their mercy in terms of fixing them. You just have to wait for your vendor to get around to it. Open source, on the other hand, anyone can look at it, warts and all, which means also malicious actors can look at the code, but also security researchers can, developers can. And so oftentimes for thriving open source projects, there are hundreds, if not thousands of developers looking at this stuff every day. So they can find and resolve issues faster than they can be exploited, which is amazing. One article once described this as the power of an angry mob of nerds carrying pitchforks and torches. And this is what ChatGPT says an angry mob of nerds with pitchforks and torches looks like. All right, so you have all these nerds that are making sure that Linux is secure. It's pretty great. Now, as I mentioned, no software is secure by default, closed or open, right? So there are best practices that need to be followed. Security scanning built into CI/CD, dependency analysis, penetration testing, third-party audits, all of these are necessary whether you're building open source or closed source. At the Linux Foundation, we have a foundation called Open Source Security Foundation, gathers a lot of these best practices, creates a lot of these tools to make sure it's easy to follow software security best practices for open source. So with that, I'll segue to Linux Foundation. So LF Energy, what we do is we cultivate the open source community around open source for the energy transition in particular. And sometimes that can be a little bit hard to understand what that means. So imagine a gym. Who here goes to the gym? Who should go more often? I should. So why do you go to the gym? You know, you could work out at home, you could do push-ups, go for a jog, but people go to the gym because it provides a place that has all the equipment that you need, has a community of like-minded people, classes, trainers, showers, towels, you know, everything that you need to increase the likelihood that you'll hit your fitness goals. But you're the one that needs to work out. It can't do that for you, right? So you have to hit the treadmill, you have to lift the weights. So just like that gym, Linux Foundation, we do that for open source. We increase the likelihood that you'll hit your open source goals, but you're still the one that writes the code. We don't do that. We provide all of the supporting services around that. And there are a lot. In order to have sustainable ecosystems, you need a lot of supporting services around building or that community around the open source technology, right? So I won't go through all these, but some key ones, neutral home, right? So we provide the neutral home for competitors to actually collaborate together. So Google, Microsoft, Amazon are comfortable collaborating through us because then they're not contributing IP to one of their competitors. We help set up governance structures for long-term decision-making, shared IT infrastructure, so chat groups, meeting planning, CI/CD, license scanning, all that stuff. Everything that you need to do open source successfully at scale, that's what we support. We also help companies on their journey towards open source leadership, right? So if you go back, right, these are the open source leaders. These are the ones who have figured out how to invest in open source in a way that delivers incredible value to their business. So we help companies on that journey as well, right? So going from consumer, of somebody who just picks an open source project off the shelf and just uses it, participant, somebody who makes a pull request, proposes a change, a contributor, somebody who actually starts a new open source project. And finally, a leader, somebody who has figured out how to weave open source into their own business strategy. And that's really the key to achieving the value that those innovative companies have. We are a nonprofit, a member-funded nonprofit, so you can see a bunch of nice logos of the companies that are working with us and funding our work. We have a portfolio of about 30 projects now that cover all parts of the energy transition, smart grid. EV charging right now represents 2 of those projects. And you can see there's a bunch of booths, and I think there'll be some presentations later on those. I won't get into too much of this because I think other people will speak more clearly on the details of Everest. So Everest is EV charging software for interoperability, Citrine OS, charging station management system, so open source, so you can go ahead and coordinate and manage all those chargers that you have. And with that, it's free for all of you to join us. Get involved, right? So hopefully by now I've piqued your interest that open source is a way for you to move more quickly together, decrease your R&D investment, improve security, have new business strategies, increase your revenue. And so the way to get more involved, we have an EV charging special interest group. There's mailing lists and Slack channel there. There's our website where you can learn more about all our projects. And then my email address if you have any questions for me. So that's all I've got. Thanks for the time. Happy to answer any questions you have.
Thank you so much, Alex. So now it's the time to ask questions. We just hand around the mic. You can just share your thoughts. Raise your hand if you have any questions.
Hey, so right now, the main interest that I have personally with working with my company is having an API that I can query to know everything about a car that's using my app. So I have login with your car, for example, and they log in with their credentials, whether a Tesla or a whatever. And this API would then allow me to query the car and figure out what's going on with the car, regardless of its brand. This kind of thing is right now behind a huge paywall. It's humongous, $4,000 per month and $1 or $2 per car that connects to your app. So if you want to develop anything like this, you have to go to the big players, and each one is very expensive. So are there, among the list that you mentioned of projects, any one of them that's trying to do this? Because what these guys have done is go to the open source existing but independent implementations of Tesla API, and they've just gathered themselves and put it behind one wall. So is there any one of these lists of companies that work with you that are trying to do this for free or less? Sorry, not open source doesn't mean immediately free. You know what I mean. But you know what I mean?
Yeah, I know what you mean. So we don't have any projects specifically around car data and metadata yet. And I think it's for the reason you described is it's a business model question, right? So these car manufacturers see this as a potential revenue stream. And so it's a question of, how do you adjust the business models of the OEM, still have revenue streams so that you can actually get that information, but at much lower cost. We have similar projects, but more on like smart meter data side, because there are similar challenges of being able to access, your residential home smart meter data. But I'd be happy to talk with you more after if you have any ideas of how we can crack this one.
Any other questions?
Hi, this is Luis from Surplus Map. I was just wondering about if you have any projects regarding vehicle-to-grid interoperability.
Sure, yeah. So, I think Everest gets into that a little bit, vehicle-to-grid. So what is it, 15.11.8-20 is the vehicle-to-grid one. So I think there's some implementations there. I think Citrine OS does a little bit on that side as well. So those would be the first places that I point you to. We all are also starting to think about some sort of open ADR implementations as well. So there is some existing work going on in that space.
All right. Are there any last questions? If that's not the case, Alex, you will be around, so you can also just ask him afterwards. And then we will have our next session at 12 from Open Charge Alliance on OCPP 2.0. So hope you join us in a few minutes again. And thank you again, Alex.
Thank you.